In this lesson, we're going to look at solving higher order equations by factoring. And in this particular case, though, we're going to solve equations by factoring out the greatest common factor. So the type of problems you're going to see here will involve the following. So the equations we're going to solve by factoring out the greatest common factor. And remember, the greatest common factor, another word that you see with it is GCF. So GCF, greatest common factor. Okay, so number one, we have and the reason we call them higher order equations is because in the previous lesson we talked about quadratic equations. And remember, quadratic equations, the largest exponent was a 2. So notice that in number one, the largest exponent you see here is a 4. So we're going to call this a higher order equation. So it's higher order than a quadratic. And remember, a quadratic equation had the largest exponent being 2. Okay, so the way you want to do this using this process here is this way. All right, so first of all, you want to make sure that you bring all terms to one side. And so you want 0 on the other side. So remember when we solved quadratic equations, we brought all the terms to one side, and we called it writing it in standard form? Well, the same idea here. So I'm going to bring the 54x squared over. So I get 6x to the fourth minus 54x squared equal 0. Okay? Now, what you want to do is notice that you have two terms here, and both of those terms have a common factor. And we're going to use the greatest common factor. So I want you to notice the 6 and the 54. So even though 6 and 54 is even, 2 is not the greatest common factor of 6 and 54. It is actually 6, right? And it's not even 3, it's 6. Because look, 6 divided by 6 is a whole number, and 54 divided by 6 is a whole number. Okay, so you want to factor out a 6. Now, remember when you did factoring in previous semesters, for the variables, you have x to the fourth, x squared. You always take out the exponent that is the smallest. So you have 4 here, you have 2 factors of x here, so you're only going to take out the smallest that they have in common. So the smallest they have in common is 2 factors of x. So you have 4 here, 2 here, you can only take out 2. So I'm going to just write this out for right now. The GCF for this problem, for this equation, is 6x squared. That's the GCF. So what you're going to do now is you're going to rewrite this right here as the GCF times whatever's left when you factor out the GCF. So I get 6x squared times, and then 6x squared times x squared is 6x to the fourth. So remember, all you're doing is factoring out a 6x squared from this term. And always check yourself. X squared times x squared is x to the fourth. 6x squared times x squared is 6x to the fourth. Minus, and then 6 times what's 54? So you say 54 divided by 6 is 9, so you get 9. You don't need any variables for x here. You don't need any factors for x because 6x squared times a negative 9 is a negative 54x squared. All right, so that was the next step. So that's where we're at, okay? Now, I want you to notice something. Now, there are several ways you can do this. At this point, you can use the zero factor property. At this point, you can use a zero factor property. You have this factor times this factor is equal to 0, right? You have this factor times this factor is equal to 0. So at this point, I can say 6x squared equals 0. X squared minus 9 equals 0, right? You can do that. Now look at this right here. That's a monomial. That's a monomial right here. So ask yourself, 6 times what number squared is 0? 6 times what number squared is 0? Do y'all agree that that number is 0? 6 times 0 squared is 0, so x has to be 0. And so you could look at this by inspection and say that x equals 0. But here's another way you could actually do this. You could get x by itself. You would divide both sides by 6, right? 6 divided by 6 is 1, so you get x squared equal, and then 0 divided by 6 is 0. And then you take the square root of both sides, so I'm going to get plus or minus, and you take the square root of both sides, and so you get x to be plus or minus 0, but plus 0, negative 0 is still 0, so you must write it as 0. Don't put plus or minus 0. 0, okay? You must say 0. Don't use this one. Do not use this one. Don't use this. You must use 0 because 0 and a negative 0 is 0. Now over here, there are a couple ways you could do this. You could solve this, since the x term is missing, you could solve this by using the square root property. You bring 9 to the other side, and then take the square root of both sides, plus or minus, and so you get x to be plus or minus 3. All right? And so there are three solutions here. Your solutions are 0, positive 3, and negative 3. 0, positive 3, and negative 3. Now make sure you understand, you see here, I say don't use plus or minus because 0 and a negative 0 is, a positive 0 and negative 0 is the same thing, is that number 0. But here, a positive 3 and a negative 3 are not the same number, so those are distinct numbers. All right, so that's your answer, that's your solution. But I also want to say this. Also, you could have, see this equation here? You could have known that that's the difference of two squares. And so you could have factored this as x minus 3 times x plus 3 equals 0. And then you would set each factor equal to 0 using a zero factor property. And so you get x to be 3, x to be negative 3. And you get this, same thing as this. Okay? All right, so notice what we did. So the first thing you did to solve this higher order equation by factoring, and we're going to use a GCF, is first of all you brought every term to one side. You put it in standard form, so you need 0 on the other side. So you can use a zero factor property. Then once you did that and you factor out the GCF, always make sure you're using the GCF. You must use a GCF. So when you factor out the GCF, we get this. And always check yourself, distribute to make sure you get this back. Then we use a zero factor property. We set each of those factors equal to 0. And then the easy thing about this one is that that's a monomial. So x has to be 0 in order for 6 times some number squared to be 0, x has to be 0. So that's why you see that. So you can go from here to this without doing this, because I would expect you to know that if you have a monomial, then x has to be 0 here in order for this product to be 0. All right? And over here, this is easy enough to where you can actually go from here to this as well. Because what number squared minus 9 is 0? Well, positive 3 and a negative 3, right? Okay. But you must write your solutions separately, distinctly. And in Alta, they're gonna want you to write it like this. In Newton, they're going to write it like this. All right. Now, you could also, for paper copy purposes, for worksheets and so on, you could also say 0 plus or minus 3. But if in Newton Alta it says separate by commas, you got to write it like this. Okay. All right. So that was number 1. Let's look at number 2. All right. So number 2, we have this one. So we have 2x to the 4th minus 8x squared equal 0. All right, 2x to the 4th minus 8x squared equals 0. All right, so notice that we're dealing with this higher order equation, and so I want to try, and there's only two terms. There's only two terms here, so that's not that difficult to deal with. But you must show the work, and we're going to do this by looking for the GCF. So the GCF of these two terms, is 2, because 2 goes into 2, and 2 goes into 8, right? And that's the largest one. That's the largest common factor. With regards to the variables, I have 4 factors of x, 2 factors of x. I got to use how many? Smallest amount, 2. So 2x squared is my GCF. Once you find your GCF, I need to see it written in this form. I need to see it written like this. Your GCF times some factor. That gives you this back. So my GCF is 2x squared. So 2x squared times, since I have two terms here, remember you're always going to have two terms here. 2x squared times what is 2x to the fourth? Well, x squared, because x squared times x squared is x to the fourth. When you multiply like bases, you add exponents. Minus 2 times what is 8? Well, 4. And then I already have the x squared, right? So I don't need any more here. So this right here becomes this. Don't forget to say equals 0. And now I'm going to set each of those factors equal to 0. So I'm going to say 2x squared equals 0, and then x squared minus 4 equals 0, right? So I set each of those equal to 0 using a 0. Remember, that's called the zero factor property. All right, zero factor property. All right, now you know what this one is. 2 times what number squared 0? What must x be? Right away, you know what that is. What is it? X must be 0. Good. Because 0 times itself is 0. 0 times 2 is 0. That's the only number that works. Over here, you can, by inspection, tell me what that is. What number times itself minus 4 is 0? All right, so you know 2, right? 2 squared is 4. 4 minus 4 is 0. But sometimes people forget about the other one. So it's a negative 2 as well. So what you may want to do is either factor it, because that's the difference of two squares. You could factor it like this, x minus 2x plus 2, and then set each factor equal to 0, right? You could do it that way. And so you get x to be 2, x to be negative 2. Or if you want to, you could use, since there's no x term, you could use the square root property. You would have to say x squared minus 4 equals 0, so x squared equal 4. Then take the square root of both sides. Don't forget plus or minus. And so the square and the square root undo each other, so you get x to be plus or minus 2. And that's what you saw here. So your solutions are 0, 2, negative 2. Okay? All right, and that's all it is. That's all you're doing. Now, I want to say this, just to be clear. Let's go back to that same problem. 2x to the fourth minus 8x squared equals 0. Okay, now this is where sometimes students get themselves into trouble. They see a 2 here, and they see the fact that a is divisible by 2 and also 0 is divisible by 2, and that's true. Both, if you want to, you could divide, just to show you, you could divide both sides by 2. You definitely can do that because both of these coefficients are divisible by 2 and 0 is divisible by 2, right? And so when you do that, 2x to the fourth divided by 2 is x to the fourth, and then 8x squared divided by 2 is 4x squared equals 0, because 0 divided by 2 is 0. And then you would factor out the x squared. The GCF in this case would be x squared for this right here. So you get x squared times x squared minus 4 equals 0. So the only difference, because x squared times x squared is x squared, and then x squared times negative 4 is negative 4x squared. What I wanted to say is that the only difference between what you see here and what you saw here was this 2 right here. Was that 2? Everything else here is this as well. And then you would do the same thing. You would set each factor equal to 0 like this, and then now you'll see, well, what number times itself is 0? Well, that's 0. And over here, when you bring the 4 over, what number squared is 4? Well, plus or minus 2. But what gets people into trouble is this. Only if you're gonna do this, only divide by the common number. Don't ever. I'm going to just say this. Do not. That's a 2 right here. Do not divide both sides by 2x squared. Do not do that. Do not divide by a variable. Because what happens when you divide this by 2x squared, all you get is x squared minus 4, and you're missing some other factors of your variables. You're missing that x squared as well. So do not divide by a variable. Okay? So when I'm going to do the problems, though, I'm not going to do this because I know that if you do this, you're going to make that mistake and you're going to be very upset because you will be missing some important mathematical statements. So when I do the rest of the problems, I am going to actually do it this way. Factor out the greatest common factor, even though, and even in number 1, even though that 54 and 6 are both divisible by 6. Okay? So I'm going to do it this way. But I wanted to bring this out because inevitably there's always someone that's going to do this. And that is mathematically not correct. Okay, so let's look at number 3. So number 3, we have this one. So we have this higher order equation that looks like this. We have 3x to the 5th equals 3x cubed. 3x to the 5th equals 3x cubed. Okay? Even though I see that both of these terms are divisible by 3, I'm not going to do that. I'm just going to bring the 3x cubed over. So I get 3x to the 5th minus 3x cubed equals 0. And then I'm going to ask myself, what is the GCF? Well, the GCF, they both have 3 in common. That's the largest common factor. And in terms of the variables, there's 5 factors of x here. There's 3 factors of x here. I'm going to use the smallest, which is 3. So my GCF is 3x cubed. So now I'm going to factor out the GCF. So I get 3x cubed times 3, oops, sorry. I'm going to redo this. 3x cubed times, and now 3x cubed times what is 3x to the 5th? Well, x is x squared, right? Because x cubed times x squared is x to the 5th. When you multiply bases, you add exponents. 3 plus 2 is 5. And then over here, 3x cubed times what is itself? Well, that's a 1, right? 3x cubed times a negative 1 is a negative 3x cubed. Don't forget to say 0. And now you're going to set each of these factors equal to 0. That's your next step. So I get 3x cubed equals 0. X squared minus 1 equals 0. This was the easy one. That monomial, 3 times what number times itself 3 times is 0? Well, when x is 0, right? Over here, you could factor the difference of 2 squares, or since you notice that the x term's missing, you can bring the 1 over and use the square root property, but don't forget the plus or minus. So the so the square root and the square undo each other, so you get x to be plus or minus, and the square root of 1 is 1. So your solutions are 0, 1, negative 1. Okay? So those are your solutions. And you can check it. Watch. If you want to check it, let's check 0. When x is 0 and you substitute in for x, both sides better be equal. What's 0? What's 0 to the 5th power? 0. 0 times 3 is 0. What's 0 to the 3rd power? 0. 0 times 3 is 0. Is 0 equal to 0? Yes. Let's check 1. What's 1 to the 5th? 1. What's 1 times 3? 3. What's 1 to the 3rd? 1. 1 times 3 is 3. Is 3 equal to 3? Yes. Negative 1. What's negative 1 to the 5th? Negative 1. Negative 1 times 3 is negative 1. What's negative 1 to the 3rd? Negative 1. Negative 1 times 3 is negative 3. So negative 3 equals negative 3. Okay? All right, number 4. In number 4, we have 2x to the 5th equals 32x cubed. 2x to the 5th equals 32x cubed. All right, first thing you're going to do, because you always want, remember, the whole process is to factor out the GCF and set each of those factors equal to 0. Well, in order for that to happen, you better have 0 on the other side. So we got to put this in standard form. So I get 2x to the 5th minus 32x cubed equals 0. And now we find the GCF. And so the GCF, oops, I'm sorry, that's 2, right? So the GCF is 2, and then you have 5 factors of x, 3 factors of x. So I need how many? Well, the smallest amount, 3. So there's your GCF. So you're going to factor out the next step is to factor out the GCF. You're going to write as a product. 2x cubed times x squared is 2x to the 5th. Right? X cubed times x squared is x to the 5th. minus 2 times what is 32? 16. I already factor out the x cubed, right? So you don't need any more. And say equals 0. Then we're going to set each of those factors equal to 0, the zero factor property. And so I get 2x cubed equals 0, x squared minus 16 equals 0. And then from there, you can go by inspection, you can go directly to your answer. So 2 times what number cubed is 0? X must be what? 0. Over here, what number times itself twice minus 16 is 0? Or if you want to, what number times itself is 16? Remember there are 2, because remember you take the square root of both sides, plus or minus. So you get x to be plus or minus 4. And again, if you wanted to, you could have factored the difference of two squares here. So it'll be x minus 4, x plus 4 equals 0. Setting each factor equal to 0, you get x minus 4 equals 0, x plus 4 equals 0. So you get x to be 4, x to be negative 4, which is what you have here. All right. So your solutions, they're for paper versions, you could say this and this. You could say 0 plus or minus 4, and that's fine. If they tell you to separate them by commas, then you must say this. You must say 0, negative 4, and 4, or 0, 4, negative 4. Okay? All right, that was number 4. So that is solving higher order equations by factoring out the GCF. Okay, number 5. Let's do a couple more. So this is number 5. So number 5, we have 4x to the 6 equals 16x to the 4th. 4x to the 6 equals 16x to the 4th. Okay, so in this case, let's go again put it in standard form, because at some point we need to use the zero factor property, and in order to use the zero factor property, you have to have 0 on the other side. So I have 4x to the 6 minus 16x to the 4th equal 0. So the GCF of those two terms is 4, because 4 goes into 4, 4 goes into 16, and that's the largest. Largest common factor, is 4. I have 6 factors of x, 4 factors of x. How many do I need to put in GCF? 4. Smallest factors of x. Okay, so then I'm going to factor out the GCF from here. So I'm going to rewrite this. You got to show this. You got to rewrite this as the GCF times whatever's left here. So when you do these problems and you have to turn those in, then this is what I'm looking for. Okay, to get all your points, you got to show all of this. So 4x to the 4th times x squared is 4x to the 6th. Minus 4 times 4 is 16, and I'm taking out all of these x to the 4ths, and that's how I write it, equals 0. Then, using a zero factor property, you're going to set both of those equal to 0. Okay? And by inspection, 4 times what number to the 4th power is 0? Well, x is 0. Over here, what number times itself minus 4 is 0? That one's easy. We've done that already, right? You get x to be plus or minus 2. And so your solutions are 0, negative 2, and 2. Those are your solutions. Okay. Number 6. Number 6, suppose we had this one, 5x to the 5th minus 180x cubed equal 0. So 5x to the 5th minus 180x cubed equals 0. So it's already 0 is already on this side, so we just go directly to finding the GCF. Notice that both of those are divisible by 5, and so that would be the largest factor for 5 and 180. In terms of the variables, I have 5 factors of x here, 3 here. How many do I need? 3. Always use the smallest amount. Smallest in terms of the variables, use the one with the smallest exponent. So there's my GCF. So I'm going to rewrite this as the GCF times, and remember there are two terms, times some binomial. So 5x cubed times x squared is 5x to the 5th. Minus, use your calculator, 180 divided by 5 So 180 divided by 5 equals 36. So it'll be 36. So 5 times 36 is 180. And I took out all these x cubes, so that's all I need to put here. Equals 0. And now using the zero factor property, said both of those equal to 0. So I get 5x cubed equals 0. X squared minus 36 equals 0. And then again, what number? So that's a monomial right here. So what number cubed times 5 is 0? What must x be? The only thing that works is 0. Over here, what number squared minus 36 is 0? Well, let's think about that. You bring the 36 over. So now you may be able to see what the answer is. What number times itself is 36? Yes, a positive 36, but what else? A negative 36. When you take the square root of both sides, you get plus or minus 6. Okay? So your solutions are 0, 6, negative 6. So that's what x is. All right, let's look at number 7. So we do one or two more. Number 7. So in number 7, we have this one. This is number 7. We have x to the 9th equals 25 x to the 7th. So x to the 9th equals 25 x to the 7th. Okay, so remember the first thing you're going to have to do is to put this in standard form. You need 0 on the other side because at some point in all the problems we had to use a zero factor property. So we had to have 0. So let's put this in standard form. So we're going to subtract 25 x to the 7th from both sides, and this is what you get. Then the GCF is going to be, notice this is a 1 here, right? So 1 and 25, the GCF is 1. In terms of the variables, the GCF is going to be x to the 7th. So the GCF is just x to the 7th. Okay? Now, rewriting this using that GCF, so I get x to the 7th times x squared is x to the 9th. And then minus 25. Y'all agree? X to the 7th times negative 25 is negative 27 x to the 7th. Then you're going to set each of those factors equal to 0. Don't forget to put equal 0. You're going to set each of those factors equal to 0. So x to the 7 equals 0. X squared minus 25 equals 0. And then ask yourself, this one's the easy one, that monomial. What number raised to the 7th is 0? There's only one number that works, and that is 0. Because 0 to the 7th, 0 times itself 7 times is 0. So x equals 0. Over here, that one's easy. You could, by inspection, indicate what the answer is. So x squared equals 25. Take the square root of both sides, plus or minus. The square and the square root into each other, so you get x to be plus or minus 5. So you have 3 solutions altogether. Your solutions are 0, 5, negative 5. Okay? All right, so that was, just to remind you what we just did. So in all these problems dealt with solving higher order equations by factoring, and we did this by first factoring out the greatest common factor. All right, so that is that lesson.